do we get BGP to recognize prefixes? Well, find out next right here on IT Pro TV.
You're watching IT Pro TV.
We are taking a look at advertising prefixes into BGP, and we actually have Anthony Sequeira with us, and he's going to tell us why we need to and how we do it. So Anthony, why in the world do we actually need to do this?
I know this is really weird, isn't it, Ronnie? If you're coming from an OSPF, IGP kind of world, you're like, you don't have to do this.
Yeah.
The prefix advertisement is automatic based on where you're running your OSPF, and it's on a link-by-link basis. Border Gateway Protocol is not like that. It is not dynamic in this way. Count it with me, everybody. There is two ways you could advertise prefixes into Border Gateway Protocol. These two methods are the network command or redistribution. So that's how we do it. Let's start in our topology by going up to the R1 device. The R1 device is in the middle of our AS. It is running IBGP. Everyone knows what I almost slipped up and said there. It is running IBGP between two of its devices that it neighbors with, the R2 device and the R3 device. And Ronnie, if we look at the BGP table, okay, the routes that have come in via BGP, there's none. It is not very exciting at all. Now, if we go out to, let's say, the R4 device, and out here, let's do this, do show IP interface brief. I bet you I have, if I can spell it right, I bet you I've got some loopbacks on this. Do show IP interface brief. I bet you I've got some loopbacks. I do. Look at this. We've got loopback 70. Let's advertise that. Now, here's how this works. If you're going to use the network statement to advertise a prefix into BGP, you must, I repeat, you must have that exact prefix in the routing table. So I'm going to do this. Do show IP route. Do we have in the routing table the 70, 70, 70 prefix? We do, with a 24-bit mask. Because that exists in the routing table, I can now advertise it with the network command into BGP. So, router BGP 65004, network, spelling counts, 70, 70, 70, 0. Use your context-sensitive help because that will keep you from forgetting the mask. You must do the mask for the subnet mask if it is non-default. So the default mask in this case would have been 8 bits. And if I was using an 8-bit mask, if it was 70, 000, whatever, and then my 255000, if it was the default mask, I don't have to use this mask command. If it's non-default, you must. So this is a big gotcha area. So there we go. We've dropped it in. It's in the routing table. I use the correct mask in the network statement. So now if we go up to R1, Ronnie, I'm expecting that to be in the BGP table, and there it is. It is marked as the valid, meaning that it has a next hop. The next hop is reachable. It does these checks to see if the prefix is valid. It is the best path that has been recorded. The best way to get there is to use the next hop of 192.168.0.4. There's the network in the mask. And then these are the various attributes that we can manipulate, some of them, to influence the best path decision. And we're going to have an episode on that for you coming up. So that show IP BGP shows us that prefix in the BGP table.
Now, I do have a question as we're looking at this. So on the left-hand side, I see an I, but we advertise this from router 4, which is in a different AS. Why isn't that supposed to be an external route?
Such a great question. First of all, the lowercase I is super problematic here. Bad, Cisco. Bad, bad. Look at what they did. They have a lowercase I here and then a lowercase I over there. Ugh. Okay, the first lowercase I is mentioned first in the legend, Ronnie. It's internal. So this I right here is telling us that we got this from an IBGP neighbor.
Ah, okay.
Yeah, and that makes sense,
Yep,
didn't it?
it does.
We're here on R1. It came in from R2, and that's over IBGP.
Right.
So we learned it from IBGP technically. This I over here, Ronnie, is super interesting. This means IGP. Wait a minute.
yeah.
We didn't learn this from an IGP. We learned it from the network command.
And that's in BGP, which is not an
Yes.
IGP.
So here's the reason
Okay.
that says IGP. The idea behind this is if you're using the network command, you're picking up a prefix you learned from something like OSPF. We cheated. We created a loopback, and then the loopback got the prefix into the routing table, then we use the network command. In production, it would be coming, most likely, the prefix you're advertising from an IGP.
Right.
So that's why that says IGP. We would never see an origin code of EGP. They could just delete this if they want. This is the older version of Border Gateway Protocol, which was called Exterior Gateway Protocol, which is now in the archives, you know, the Museum of Natural Science and Computer History. There is no such place. I just totally made that up, Ronnie. The incomplete we're about to see in a second. That's when we redistribute in. Are you ready to see that, Ronnie? You
Yeah,
ready to
let's-
see a little redistribution in?
Yes.
Okay. I'm going to show you.
That
Let's go
sounds
over to router 5. Router 5 is out there. And you know what? We'll get a quick review because the router, you know what? Instead of setting up another EBGP peering, that'll take too long. Let me just do this. Let me go over to the R4 device where we use the network statement, right, Ronnie?
Right.
And now watch what I'm going to do. I'm going to say redistribute into BGP all of your connected interfaces. That's it. Redistribute connected. So if we look at the routing table here, show IP route, we have all of these many connected interfaces, and they all just got redistributed into Border Gateway Protocol. So now if I go up to the R1 device and I do a show IP BGP, holy prefixes, Batman.
That's a lot.
Look at all of those prefixes that we just redistributed in. And Ronnie, you can see all of them have the question mark to indicate they were advertised into BGP through redistribution, except for the one that is overridden. And that is because we used the network statement. So we just learned something there. The network statement would take priority over the redistribution approach. Pretty cool.
Yeah, there's no doubt that being able to use this. So these are techniques that we did learn a little bit about during our CCNA as far as the redistribution. So that shouldn't be too difficult for us to get through. Now, once we do that, since you actually just advertised it and it went up to R1, do I have to go to R3 and configure something else to make those routes come all the way through?
No, because let's go back and take a look at our topology. That's a great point, Ronnie. Watch this. If we go in here and take a look at this situation. So we have been taking stuff from the R4 device here, and we have been advertising it either using the network command or the redistribution. We've been advertising it across an eBGP peering into the R2 device's BGP table. It has an IBGP peering with the R1 device, so it sends it to the R1 device. And then the R1 device sends it on to the R3 device, and then R3 sends it on to R5. There is a little magic that Ronnie and I had to do inside of this AS right here because of something called the IBGP split horizon rule. Remember, the IBGP split horizon rule says, if you learn stuff via IBGP, don't advertise it via IBGP. So we did a route reflector configuration inside of AS65213 in order to work around that split horizon rule. Not a big deal for us in the Encore exam, but I did want to make sure that you were aware that we did that behind the scenes. because we did that configuration, because we did that configuration, we should have those prefixes go from R4 to R2, R2 to R1, R1 to R3, and then R3 all the way over to R5. So a really fun test here is going to be for me to go over to the R5 device, Ronnie, as far away as possible from the origin of those prefixes and to do a show IP BGP. And we never even set up R5 for BGP. That's hilarious. But if we did, it would be there. Let's go as far as we did configure BGP, and that's all the way over to R4, show IP BGP. Is that the farthest point away? Now I've got myself a little confused on the top. R3 is the farthest away. Thank you, Roddy. So if we go over to R3 and do show IP BGP, we see all those prefixes. So they made it all the way through the topology on their own. Ronnie, that was dynamically done. So there is dynamics at work here. It just wasn't with the prefix introduction.
Yeah, so Anthony, that's actually a great point for us to think about. Now, we will end up covering IBGP.
IBGP, you got it.
At some point, but I don't remember if it's actually an encore of us in a future
Yeah, we'll
show
be
that
looking at it for sure in our NRC.
Right. So don't get overly worried right now. This is specifically what's called out on the exam, is that we understand this idea of the advertising prefixes here. So Anthony did show us a couple of different ways, right? We could use the network statement, or we can redistribute into BGP. And what we're looking for, of course, is that you understand all the output that you've seen using those show commands as well. Well, that's a great place for us to end this episode then. Signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.